For this problem, problem 6, you have to consider the meaning of absolute value is a measurement. So what that tells us is that the result is always positive. And since it's always positive, it's not possible for it to be less than negative 12. So the answer is no solution. For problem 7, the first step is to isolate the absolute value. So we want to add 6 to both sides. That'll leave us with the absolute value of 2x minus 4 is greater than negative 3. Again, this is always positive. Therefore, any value will generate a positive value, so it will always be greater than negative 3. And that's just because the result from the absolute value will always be positive, so it will be greater than. So the result then is all real numbers. You can put that with negative infinity to positive infinity. For problem 10, you want to start by actually taking the absolute value of negative 4. That's going to equal positive 4. So we'll bring down the first absolute value. We've got the second absolute value simplified to 4. Now we can subtract it from both sides. And that's going to allow us to isolate the absolute value. And now we can separate it. It has to be less than 2 units from 0. So when you go to separate it, it becomes negative 2 is less than or equal to 5x plus 3 is less than or equal to 2. What that does is now allow you to solve that for x. You want to get x in the middle, so we're going to subtract 3 from all 3 parts. So negative 5 is less than or equal to 5x is less than or equal to negative 1. Now you have to divide all 3 pieces by 5. We're dividing by a positive, so it does not affect the direction of our inequality. Okay. So we get negative 1 is less than or equal to x is less than or equal to negative 1/5. And then for the interval notation, because of the equals to, you would have a bracket on both ends.